Hi, folks. My name is Harsh, and welcome. I welcome all of you to our April community meetup, where we are going to talk and discuss about how you can use open source tools to simplify your cloud development and testing. Today, we have got two exciting speakers with us, and they will be talking about the two topics that I love to hear about: serverless testing and streaming analytics. As always, the meetups are going to be jam packed with a lot of technical topics, really cool demos, and a lot of insights from our speakers who talk about how you can use these tools to drive your development and testing workflows in a smart fashion. So, without much ado, let's jump into the agenda for the day. So first up, we have got Kamesh from Snowflake. And in fact, I had the pleasure of meeting him about a couple of months back at one of the in-person meetups that we were doing. And he would be talking about streaming analytics and the traditional challenges that one might encounter while building them. So he's going to walk us through something that I have never seen before, a complete local first streaming pipeline that is going to be running on a laptop with tools like LocalStack, Apache Iceberg, and Streamlit. Next up, we have got Manuel from Docker and Test Containers team. And in fact, if there is one thing that I love absolutely in the testing space, that's gonna be the Test Containers library. And I have had the chance of like meeting with so many great folks from that team. So he's going to show us today how we can test Go-based Lambda functions locally and reliably before shipping to the cloud. As always, using the evergreen Test Containers library. So let's go ahead. The next up is intro and welcome. That's what we are doing right now. But let us bring both of the speakers to the stage and yeah, let's have a chat directly with them. So, hi, Manuel. Hi, Kamish. How is it going for you?
Hey Harsh, super nice to meet you again after a couple of months, and obviously meeting Manu like after a long time. Over the Life Ray thing that we did 10 years ago.
Yeah,
It's been pleasure working there and knowing him. Yeah.
that's
Yes,
awesome. I guess one of the.
oh, I was
Uh-huh.
saying, what a coincidence. Thank you for connecting us again. I'm really blessed to stay here with sharing the stage with you.
hmm Definitely. I guess one of the best parts of doing this meetup is that it gets me an opportunity to bring two parted colleagues together in one session. It's like you folks worked 10 years back and now you just happen to find yourself again in a virtual session. So that's pretty exciting. Uh, so I guess, yeah, that was pretty great. Thanks a lot for accepting our invite and being a part of this meetup. Uh, just one quick call to action before we jump into the individual sessions is that, as always, we run our Q&A on Slido. So if you have got any particular questions or doubts, you can just directly go to slido.com. You can put this code right over there, or you can scan the QR code and just join the Slido session directly. You can also put your questions directly over the YouTube Live or LinkedIn comments, where this is being live streamed right now. And we can pull them back and put them directly for our speakers over here. So, with that said, and just keeping the introduction simple and sweet, let's bring the first speaker for the day, Kamesh, who is going to tell us about how we can build a local streaming pipeline. So, over to you, Kamesh. The stage is all yours.
Hey, thank you so much, Harsh. I think I hope everyone I'm able to clear. I think Harsh, just a request from my side since we're doing a virtual. In case if there's a drop or something in my voice or people can't able to hear me or something like that, just stop and call me out so that like it's easy for me to put back because there's always the technical stuff is always going to have something here, right? I think one thing I want to call out before this, I think thank you so much for bringing me and Manu together again. So, but one thing which again brings us together, I think 10 years back, open source at LifeRay brought us together. And again, open source now again is bringing us together again with doing these stuff. I think that's exactly the topic that you see on my screen. How do we actually stream, store, and ship the stuff, right? Real-time analytics using bunch of tools. I'll share the tool stack and everything, and it's completely open source demo. I think probably I'll share the repository. I'll share the instructions when I walk through the demo, so you know what I'm doing, etc., etc. Right, and I have the resources right here in case, like, if you want to go ahead, try the whole stuff out and all these things. I put on a bunch of tutorial links, the documentation links, and every other tools that is used to build this stack. You can just go ahead and start doing it. And then again, I'll add it to Arsh so that like you can also put up in the meetup page. Right? Awesome. So what's next? Just a quick overview about what I do, streaming across like in the industry right now with Snowflake as lead developer advocate, based out of Bangalore. And then like I said earlier, like in case if you have any questions on this session or anything else, you love to collaborate with me. Like I have put down my social handles. You can find me on LinkedIn and GitHub. And these repositories are open source. Put up an issue there. We can chat over there to kind of improve all these stuff. Right. Awesome. Before I go down this track, like this is something like which I always want to do a little refresher about, like what's this EDA, event-driven architecture, is all about, and why people are so fascinated about, and how real-time analytics, the underexplored area of the analytics space, it's streaming analytics, is something which I want to touch upon. But in the interest of people who are fresh to this whole topic of event-driven architecture, understanding like what these various terms like data streams, event producer, event consumer, and all these stuff, I just want a little touch upon what these things actually mean to us and why we want to use them, right? Basically, imagine like on the top left of the screen, like I just tried to draw a few things around. I think I just said, okay, data streams are nothing but a continuous flow of data, as you know, like for example, a stream of orders, stream of users, stream of employees, or stream of from the IoT devices sending some signals across and all these stuff. And the biggest thing about this is like when the streams are just flowing, right? It's totally of no use, right? For example, I use the classic example of when a river is flowing into the sea or anything like that. Unless and until we take the water on your glass and drink it, like it's not going to be of any use. That's exactly the same thing I want to draw here. Unless until a stream is changed into an event, the stream is of no use. Again, I call this as always. I try to put that even in my blogs. Like data in isolation is useless. Exactly like what I want to talk here. Data streams converting an event. There is no change to this except that event becomes a digital record of action on time. I put up some examples there. Joe joined an Acme on a particular date, order for 2 pizzas, placed at 12 p.m. and all these stuff, right? We're adding some timestamp to the whole data stream, right? The data that is flowing inside. That's where it gets more interesting for people to kind of go find out, hey, what I can do with this data, right? For example, I can go and find out who all the people joined this organization on 25/10/2023. That could be a classic example along with Joe. I could also say like what are the orders that been placed at 12 p.m. For the 2 pizzas, what are type of pizza that's placed, right? This gives you another analytical thing that you can go for, like who placed it, where it came from, right? A lot of things that comes into the picture which kinds of feeds into as a food for your analytical thing, right, that you want to do. Cool. So, but again, there are two more stuff that I want to touch upon. Basic entities, like any blogs that you read about, you'll be reading about only all these things. There is an event producer, obviously the guy or a person or an entity that produces an event. There's also going to be an event consumer, again, an entity or a person or a system or anything that's going to consume this event. These are the two guys, or two parties, I should say, who gets involved when kind of event is flowing through this. When I build something around this, right, and I build something around event-driven, right, that's called event-driven architecture. It's a software architectural style where I build application using events, right? I think that serves as a very basic refresher for our staff. Like people are new to this, like you can read more about. There's a lot of blogs which talk about producer, consumer, the architectural styles, etc., etc. But what gets really interesting is that the technology stack that we kind of going to use this to kind of build this. So one of the examples, like the moment I joined Snowflake, I was kind of like, I want to understand like how do I build this analytics? Obviously, we are AI data cloud doing analytics in cloud, doing all the stuff. I was wondering how do I get streaming data, put it with Streamlit, and kind of get this data analytics done, but all on your laptop, because I'll talk about why I want to do this and why I did this as well down the lane. Right? Obviously, a de facto tool, when I talk about streaming, everybody's mind comes is Apache Kafka, right? I think nothing more than this is going to be the better streaming platform that I can basically use to start plugging into my application to do streaming. Obviously, the key capabilities, stream, store, and ship. That's exactly the title which I kept, like I can now stream and store. But one thing I want to call out here is that Apache Kafka is not a database. I think that's something people have a little, like why I can't do anything here. I stream some data. It will be there on a persistent storage for some time. Obviously, there's a retention period. It's always there. But after some time, it basically goes off. And only use case that we're going to see today is like there are other use cases as well, which I've listed here. But for today, we'll just see about real-time analytics. How, as something like, for example, I'll be taking a balloon game example. I share the data when I show the demo. But that's where I'm going to use that to kind of build a dashboard using real-time analytics, right? Well, there's other use cases like event-driven architectures, microservice communication, log aggregation, and stream processing. There are all of these things that Kafka can capable of doing it. But please bear in mind that Kafka is not a database. That's something which you need to have. Any streaming platform that's not a database. Now the question comes to you like, okay, what should be my next technology tool that I basically need to get this data into a database? That's where any kind of a streaming database, Rising Wave, is one of the streaming database that I'm kind of used. There's 8K GitHub stars, again, open source, 2.5 lakh stack members. I don't want to read all these things that's on my screen, but you can go find out Racing Wave. Just Google around. I think I have the links down in my resource documentation that you can also find out. So this is going to be a streaming database. Streaming database, basically, it acts like an intermediate place where I can store something on a persistent storage. For example, get a stream, do some transformations on the data, and store it across and send it to multiple different places to kind of do this data cross, right? So that's going to be what I call a streaming database, end of the day. But there's another problem that actually comes in when I got the data streams done. I kind of persisted using a streaming database or extracted the data and do a dust transformation about all these things. But where do I store it, right? So the basic problem that comes in storage when I want to kind of store the data in a particular day, for example, let's say PostgreSQL, right? When I store the data in PostgreSQL, only clients or consumers that can understand PostgreSQL as a language can consume this data, right? So when it's not going to be, when it's, let's say I want to have something like a SQL engine agnostic kind of a thing that I want to do, that's where things like Iceberg platform comes into the picture, right? Because once I do this data, the analytical data that I'm getting out of the streams, it will be consumed by multiple different consumers. I want to have one format to store the data. I don't want to repeat the whole stuff that I'm doing. That's where I thought, okay, let's use Iceberg to kind of store all these data in Iceberg format, which is open table format and Apache Iceberg. Processing engine agnostic as listed on the screen, which means that multiple query engines can query the data. Right? That's another thing which I want to add to the whole flavor, right? I didn't want to write the same stuff in multiple different SQL understandable formats so the different engines can query and take the data, but I want to have one format which multiple engines can query, making my query much more easier, much more faster, and much more standardized across. That's what I mean by processing engine agnostic. Advanced table features, when I mean by that is like, for example, when you have the streaming data, right? Basically, let's say I have an employee streaming data flowing in. So let's say first time I have employee first name, last name, and let's say email, right? Which flows in to the same. I'm just taking a very simple example. Now understand there's some changes going on in the application, and I added, like say, the address of the employee as part of the stream. Now, when this is getting consumed by streaming database or an underlying database format, what basically happens is that I have to go back and change my schema, have to go back, do other stuff, take the backup data, roll back the data, and do lots of other database data ops thing that I need to basically do. But with advanced features of Apache Iceberg, you don't need to worry about this because it allows you to do schema evolution, which means that I can pump the data as it is. It can adapt and then add a new schema and then store the data in the same format. So engines, which is querying an old schema structure, can still query it, and engines using the new schema structure can still store it. It's not only that schema evolution, it also helps you to doing partition evolution. I can also evolution the partition of that stuff. I can also do time travel, go back in snapshots and go query in a particular time in case if I had done an accidental update of this. Again, so these are the advantages rather than just a schema change, a REST or common format. It also gives you these advanced table features. Again, performance optimized because like each metadata, I'll show you that when I actually show you the demo, it stores all the snapshots and all the partitions. So which means that by default, it can also go do the partition pruning when I kind of go querying the data, which means your queries are going to be faster because when it goes to the metadata, find out the information, just one file that's going to read that, it knows the place where to go query the data and get back. And enterprise governance is ready, which provides ACID transactions, safe concurrent writes, and audit history for the data lake environments. So these are the big advantages that I see bringing in Iceberg into this whole scheme of things in technology stack when you want to build something like a real-time analytics application. The other one that I also want to bring in here is like Apache Polaris, which is incubating in Apache again. So it's a REST-based catalog. There are various catalogs that is available to be used with Apache Iceberg. But in this case, I'm going to use a REST catalog because it makes the whole thing lightweight. And also it helps you to kind of build something like what I did, like in fraction of seconds, doing something running on a laptop to do all your experiments and other stuff, right? I listed down some of the things. The REST catalog is actually Apache Iceberg. Apache Polaris was a Snowflake's contribution to the open source thing, right? Right now we have the REST catalog that is available with us so that you can query the REST catalog. The big advantage that you get with this particular kit, which I developed right now, is that like you can always use all open source. And once you decide that I want to use something like an open catalog, which is a managed service that's provided by Snowflake, you can just flip the URL, everything works fine. So that's as simple and as easy as that because it's all going to be on REST. It's going to be done over the REST protocol, which is simplified, decoupled architecture, open standards, which are always there, right? And more than all, if you think for a second, like everything is done using Kubernetes on your local stack. I mean, with local stack on your machine, which means that like you are already doing a cloud native data application building, right? That's another big advantage that you get, so that you don't need to worry about how do I take this application when I'm kind of going to do it with cloud or other stuff, right? That's another one. I think probably like we can read more about Apache Polaris. It's a very simple, easy to use REST server. It's a Java based one, which means that you can also do Java jar, start your microservice REST servers on your application and start communicating with it, right? So these are the other ones, like which is the core of this whole stack, and where we had like, okay, both Apache Iceberg needs some kind of a persistent storage where I basically go store the data. For this whole example, I thought to use S3 as my object storage. Is a very common format that's used across, but also support Azure storage, GCP storage, and all of this stuff. So, but one of the hiccups that I got right now is like, okay, I want to do S3, but I don't want to kind of go do it from my laptop, but I don't want to go to the actual cloud storage because it's going to cost me something. So I just want to do some experiments before I actually go ahead and actually use the cloud for the production or higher environments, right? That's where I kind of brought it, like I'll come back to the Streamlit thing in a second. That's where LocalStack was used, right? It was able to allow me to kind of do all of the stuff locally, right? All AWS services, everything just right from my laptop without fussing much about like what is my AWS credentials, STS, all other kind of mechanisms that comes into cloud-based deployments, right? But still it is ready. All I have to do is like when I go to the actual AWS cloud, in this case, I just need to flip the AWS key, secret key, and access key and other stuff, and things starts working very simply and easily, right? So for me, to do experiments, to do POCs, POTs, that's basic thing that every organization does before they actually jump into it, right? That's where LocalStack came into. It's very handy. I recommend this for everyone who's want to try something around cloud, especially on AWS. Do something locally before you actually move to the actual cloud-based deployments, right? That provides more stuff. Probably would have heard from people from LocalStack community, like on all of the meetups that happened earlier on, right? Great. The other open source stuff that's basically going to come here to build my analytics is Streamlit. Again, Streamlit is again open source. You can go there to streamlit.io to kind of find more information. It's an open source web framework in Python. The biggest part of this is like it turns data scripts into shareable web apps in minutes. I'll show you when I actually show the demo, like how it's easy is for me to take the data, query the data from Iceberg, and just show the data in a visualized format. No front-end experience required. We have tons of features that's available in Streamlit that allows you to kind of go build the stuff so easily. So without much effort, right? I don't need to be a front-end experience like drawing all those widgets, right? Which is hard, I know. I respect all those people who does this great front-end work. Like Streamlit allows you to concentrate on only things like visualization of data, generating charts, showing the charts, and all of the stuff and all these things, right? Focus on the data and model, right? That's the more focus here because I'm dealing with data, getting data, doing some analytics, right? So I think it's talk about the data. This is how I'm going to totally wire all things together. So like there's going to be data streaming platform we talked about. We're just going to have source and sync where that's going to come up. And then I'm going to use Apache Iceberg, which is going to use S3 emulator from LocalStack, AWS S3 emulator from LocalStack to kind of store the data. And I'm going to visualize the end of the day using Streamlit. So that's the whole architecture, or to say the technology stack that I'm going to use here. All right. Awesome. But there is something which I want to highlight before I actually jump into demo. Like basically, like what was my motto to kind of do this whole stuff, right? Though there are something which I will kind of my personal stuff, personal gains, other things I'll share in a second. But most importantly, I want to solve a bunch of stuff. First is a bloatware problem. So what do you mean by that? Like most existing data catalog and tools come with heavy dependencies and heavy configuration that makes the whole container-based development super hard, right? Which kind of I call as bloatware, right? If you remember, like I take this classic example of running Ubuntu on a Raspberry Pi and running Ubuntu on your machine, you see how much bloatware you carry always, right? So that's something which I want to avoid basically. The second one is like these tools are does extensively super job across, but there is something which I felt was there was a developer experience gap. How easy is for me to run all these stuff right from my laptop before I actually go and do it in actual production-based deployment? So and also carrying the same thing, right? As I said earlier, laptop-friendly development environment, so that I know what could be the potential issues that I might be experiencing when I'm actually going and deploying this in the actual cloud or wherever it is, right? Cloud native integration. I want to understand what are the cloud native patterns that I can apply earlier on, so that I know what could be the potential issues down the lane. All right. And also, I want to tell you something, right? when you start developing something, right, one of the things which always comes to people's mind between is like time to value divide, right? So if I'm going to spend too much of time configuring something, deploying something in a real cloud-based environment, which is a classic production use cases, I'm going to lose a lot of time before I can take my feature into the market or do some analysis or derive some insights from my data before my competitors and other people who come and then take this out, right? So that is where again the problem comes, right? Because the time to value divide is very, very important when you are doing the actual business, especially an analytics thing, which where we are deriving insights. You want to derive the insight quickly, understand the whole problem, and go to the market quickly, right? So if you're spending too much time on doing the whole stuff, again, the time to value will increase, which means that I'm kind of going to lag behind my competitors when I'm kind of doing my business. That's another soft side of this whole technology stack that I want to do, like against these two things. The same thing comes back here at expertise barrier. I might not be an organization which will be having somebody who can configure Kubernetes or cloud or AWS and everything. I have all data people, data engineers, data scientists, and data analysts in my company who are super duper classic, having skills to kind of do this stuff on deriving analytics from your data rather than spending time configuring some stuff, deploying on cloud and everything. So again, this directly relates to time to value divide again. So since I don't have expertise, I might be spending long time configuring something down the lane, right? And last but not the least, testing versus production reality. So this is again a very important thing, right? This is core of any DevOps principle. Again, that's what even I want to apply for the data world as well, is because what I test on, what I do my development on every day should be my actual testing environment or actual production environment, so that I can identify the defects super early on and start of fun to fix them up so that like it doesn't seep through into my production and I come back to the whole cycle, right? So that's again another important thing why I kind of do this whole stuff, right? Again, I touched upon all these points. Again, it's a personal pain. I want to kind of bring all these tools together to kind of do some POCs and POTs to understand something. Democratization goal, which I want, make advanced data governance access to all developers like Iceberg in your local, Polaris in your local, and then do some testing, do some POCs on other stuff. A learning journey, so which means that create hands-on environment that actually mirrors the production, right? So it's again, I want to do something and that journey as well. Focus shift, focus on what I want to do, right? Analytics, I want to derive analytics from streaming data rather than spending time configuring my environment. The evaluation need again, before none of the organizations will straight away adopt some technologies immediately, right? I want to do some experiments with this, understand the risks, what are the pros and cons, before I actually go back and invest some money on this to kind of get this environment deployed in actual thing. That's another one here. Developer friendliness, we talked about, and cloud native, we also talked about, right? I think that's pretty much I have. But before I get to my demo, which is going to be a short, sweet demo that I want to show, why I'm doing this with streaming data, again, applying dry. I don't want to repeat yourself. What I mean by this is, right, as I said earlier when I started using Rising Wave or other stuff or all these kind of things, and I want one source, Kafka here, and multiple things. That's where Iceberg also comes in, because I will be able to query with multiple query engines with the data that's coming from Kafka into Rising Wave streaming database and the other stuff, right? Again, keep it simple and straight and stupid, because I don't want to learn another DSL, another language, and other stuff. Since the data world is always proficient with SQL, I just want to keep things super SQL and SQL only, right? Even better, I also wanted to make it cloud native, deploy it on Kubernetes, make it available so that I can take the same deployment, same manifest, and deploy it in an actual production grade Kubernetes environment. Lastly, I can also build time series database in between using Rising Wave streaming and everything put together. Okay. I think that's pretty much about the talking. Probably I'll just jump into the demo. Probably I'll stop my presentation and then I want to split my screen up. I think I hope my screen is good. So you can find this complete stuff. I'll share the links on my once my session is done on the chat, so that Harsh can share that with you. I kind of put this more detail, share you about the architecture, how I build this. This can also mimic your actual production architecture as well. And then like I have the instructions put down here. How do we set up your environment and everything? Just a clone, for example, you clone this stuff. I already did this cloning here. Set up a bunch of environment variables for you to use. I've been using Apache Iceberg for showing the demos and other stuff. That's the reason why I'm setting up a bunch of environment variables for me to do this stuff. A little of hacky things that you usually do within your local environment for routing. I think that's something which I'm doing for LocalStack. I think LocalStack documentation also has information about it. But I had an extra information how to use DNS mask so that you don't tamper with your ETC host. It makes things much easier, right? Once you're done with that, then I just ran about creating this little Kubernetes cluster with K3s. I already did this little preparation where it creates a bunch of files and everything. I give you an example about what all the other things that I use here. I use Ansible automation script. That's another thing which I want to highlight here, is because this is a starter kit end of the day, but I also added some automation into it, which is very much needed for the DevOps world, which means that tomorrow when you're going down to actually do the job, to your thing, like you can take these scripts as a base and then start building that upon it or improving it for your own thing, which means that it also gives you an idea how do you basically automate something like this for your actual environment. So I did this prepare. I just created this cluster. I already have this cluster. Let's go and see kubectl get info, cluster info. Okay, I should get the cluster info now. Okay, all the cluster run here right now. So that's all there. I'll frequently using CLS because just to make sure that I'm putting the command right on the top of the screen. Probably I'll just drag a little down so that I get more space for my upper screen here. And the very first thing I did was like I had a bunch of components, as you know, right? I just list all the namespaces. I have a Kafka namespace where I deployed Kafka. For example, let's do get Kafka -n Kafka namespace. So there's one Kafka cluster that is running using Kraft, which is deployed using streamz.io, which has the Kubernetes manifest for you to run. Then I have LocalStack, which has the emulation running for me. I think the interesting thing to see in LocalStack is the services. -n LocalStack. So I have the bunch of services which is running in a lot of other stuff. The only thing which you're interested to now is endpoint that I'm pointing right now here 4566. And then I route it to the local so that I can still do the all kind of local routing with this. K3s, I have those details about how do we actually do the local routing and all of the stuff, right? So what else I have? I have Polaris, where let's see what thing I have in Polaris. I have the Polaris server running up, the machine using PostgreSQL as a meta store, and a bootstrap thing that bootstrap all the credentials and other stuff that I require for Polaris. So I have all those things. And last but not the least, I also have a bunch of stuff running in Rising Wave, also running this meta compute compactor and all these stuff running for me to kind of do the streaming database thing from Kafka to Iceberg and all other stuff. Okay. So the good thing about this is that I can always check for all the stuff with the playbook thing. For example, I'm just going to check if all my components are ready. So before I can go out experiment with this, I think it goes checks each and every component that is deployed there, make sure everything is ready for you to go ahead, right? I think the same thing I can also do to make sure everything in Polaris is also ready for me. That's the stuff I do here. Same stuff, different set of components and all these things. That's where your automation comes into picture, because it's easy for you to kind of make sure your environment is ready for you to go ahead and do this thing. Okay, that's there. And then finally, I have a bunch of services that you can access. The very first thing that I have to do is like, I don't have LocalStack here. Let me go here, refresh this tab. It is running right now. You have a resource browser, which basically goes and finds out all the resources. But for today's demo, like we are more interested in S3, which is the thing that I want to show you from there. So probably you can just go find out S3. I don't have anything here. So that's where the whole stuff is going to start playing around. Let's go here. The very first thing that I have to do right with Polaris is that I have to go ahead and do the catalog setup. The catalog setup is basically like something I have to create a catalog, credentials, principal, roles, and everything. Right? It's a kind of a 7-step thing that we usually do. I kind of automated those 7 steps from the user perspective with the variables, which means that you can also go find all the stuff that is there. I think the tokens are also masked here. So if we go back to LocalStack right now and just do a refresh, I should have a balloon game, which is the mimicking. I'm going to mimic a balloon game here. So that S3 bucket is being created, but the bucket is empty, right? So don't worry about this. The bucket is empty right now. So because I don't have any data actually added to this, which is what we're going to do as part of next steps. And I think you'll also have a verify Polaris to verify the setup and everything. So which also acts as a, so Polaris, I have a starter kit, probably I have a documentation link for that, which basically allows you to set up LocalStack with Polaris as the backend that you can start using it, right? So I gave a detailed analysis about this little demo, which is a balloon game demo that basically mimics the balloon data, where people are playing this little balloon game. I'll show you the schema structure in a second. So what I have done here is like I've given a detail about like what tables that we have, what this table means, what is the column types that we have, and how are we doing this, which is optimized for what, etc., etc. So that it's easy for you to understand what all the tables that we are going to create. I'll create the tables in a second, right? To create the tables, what you can do is like, let me go to my VS Code here. I have basically a workbook that comes along with this repository. So where we are going to create all the stuff, like create the tables and other things. So let's go and create these tables and just go into little imports, where we can go do the imports here and then query. The other one is basically, I'm just going to do one by one. So just do this query, the Iceberg version that I've used here. So there is a principle that gets created, which required for us to kind of go interact in the REST way along to your database. That's what we're going to do with Iceberg stuff and some variables that I'm defining. This is the very first step, interacting with an Iceberg Polaris catalog. To Iceberg using Polaris catalog is what we do here. We supply the credential, client ID, vendor credentials. This is another interesting thing about Polaris is that once you configure Polaris with the credentials, you don't need to pass the AWS or Azure or GCP credentials every time you do this. That's what we mean by vendor credentials here. So probably Apache Polaris and together itself is a separate session. Probably you'll do some other time. I'm just going to create the REST catalog. I'm going to create a namespace, a database. Technically, I think this should already be there. So that's what it says, a namespace already there. When I did a catalog setup, I already automated creating this whole stuff here. This is where things start get interesting. The very first thing that I'm going to do right now is again, I'm using schema here, Python Iceberg library to kind of create a leaderboard table. That's what it does. It takes a little bit of time. So let's go here to LocalStack and see what happened to my stuff here. Let's go refresh this. You see Balloon Pops database or namespace created. The leaderboard schema is created. Only the metadata is right here. The metadata is technically empty. Let me make it a little bigger once I start running the whole thing, right? So, but you'll see this whole stuff getting populated with more and more tables, more and more files, typically the Iceberg files that gets formatted. So let's go back here, the interest of time. Let me go run this statistics, color statistics thing again. We'll talk more about that once I start the simulation. And real-time score, there's a bunch of time series data that I'm creating here for the analytical stuff. The real-time scores where the player scores get created. And then I'm also going to do the colored pops, which means that what color pops that each user or each player is doing. And also like color performance trends. These are the various analytics that I'm deriving. I'll show that on the analytical dashboards once we have it running. And those are the tables that we got created. And we are right now ready with all the tables. If you see there are a bunch of tables that I created here for the real-time scores, leaderboard, color performance trends, etc., all got created. So the power that I'm getting with LocalStack here is that when I'm kind of creating all these Iceberg tables, instead of querying my S3 every time to see the metadata, to see the files, to see the Parquet files, or see the structure of the whole stuff, I can go look at this stuff right here. So I'll show you that how we actually see that. Right now, as I said, the metadata is empty. Let's go back here. And I've done this table creation. I created all these tables as you saw. I'm going to start the pipeline basically right now. So the very first thing that I have to do to create the pipelines is, let me go to my thing and also keep this one right here. I have to create two SQLs. Basically, I have to create sources and sinks. That's what I'm doing right now. If you go back to my sources here, if you go to the scripts, there is one source, basically the balloon game events. It's connecting to my Kafka cluster within my Kubernetes thing. I have a bunch of materialized views that I'm creating from the data and dumping inside this, right? And also, since I'm going to run this in streaming database like Rising Wave, I can also do tumbling window and all these things for interval. It's making this 15 seconds because it's going to be a short demo. So I just want to go show the statistics pretty quickly and easily. And lastly, like this is a sink that I'm creating where this data going to be synced into Iceberg tables. You know that we are running Polaris. We have this. The Polaris credentials is local credential that is there. LocalStack is used as S3 endpoint and all of the stuff that we configure here or S3 access key. End of the day, when you actually do this stuff in a real production scenario, you're just going to flip these things or leave it to default and other stuff. Okay. I get to the source and sinks. What I'm going to do right now is go back to my instructions. I'm just running the instructions so that like tomorrow when you run this stuff, it's easy for you. Sorry about that. I'm going to create a source. There's going to be source and materialized view. The ones which I showed in my SQL are getting created here. We're done with that, and let's going to go ahead and then create the sinks. Let me go here. Once I create the sink is done. I think probably like I have to take an excuse from Manuel and Harsh that I'm just slipping a little over time, if I'm not wrong. I'm almost done with my demo. So right now we can also go use PSQL. I think Rising Wave uses PSQL syntax, which means that it's easy for you to use PSQL client to get into this whole thing and start other stuff, right? All right, so again, let me jump to actually running the application. So what I'm basically going to do is like, this is the event structure. If you remember the first time when you talk about the structure of data, there's going to be a player name, the balloon color that is popping up, the score, if it's going to be favorite color or not favorite color, and then kind of the event timestamp, because event is very important when you're leading with streaming analytics. This is without bonus hits. When he's going to do a bonus hit, there's going to be double up some points added to him, and this data is going to get there so that you can see various statistics around, right? So what I'm going to do right now is going to generate this data. Actually, I have an actual app that actually plays it, but for this demo, I'm just keeping it that it's kind of generating this whole JSON structure that you see right now. So what we'll also do is like, while that happens, we'll also try to visualize the data, right? So I'm just going to start the Streamlit dashboard right away when it's running. And I'm going to go to the whole streaming here and then click on home here. The data is running behind the scenes. And as you see this whole stuff, let me wait for some time. The whole Streamlit thing, let me go. Yeah, there you go. You get the leaderboard here. It takes some time for the data to be synced. And you see this, the top 5 players who are coming here. We get some leaderboard score analysis being done using the charts. Let's refresh this. Let's go to color analysis where I do some heat charts. Again, split by player. Let's say Gentle Dragon. What does he does? He has white color as his favorite. Some heat map around it. Some color statistics, right? I think you'll be astonished with the data that we are generating with just a very simple balloon popping game. Imagine like what analytics you can get from your actual business data, right? So let's go back to this again. I think somebody else, the Mighty Star, has actually come up. You should see this again, these graphs saying me like it's line from. I think I kept it 15 seconds because I can get these nice analytical graphs for you, how many bonus hits he has been done, etc. Again, going back to the performance trends again, you can also do a little bit more statistics here by a specific metric. These are the balloon pops, how many pops he has done over the time. I can also go by points by color. So how much is impacting this particular person's color? By points, how many points is scored in each of these colors? And also like you can also go back and do bonus hits. End of the day, how many bonuses this particular player has hit. I think you can also go back and find with another player. So this kind of interactive dashboard is possible with Streamlit. With very little code, you can do this, all these magic that you're seeing right around. And also let's go back to the leaderboard and see who's leading this, and you'll see some statistics about this. This Mighty Star is still leading this stuff. Let's go and find out the player Mighty Star's statistics here. How many points? I think he's scoring blue is the favorite color, and that's my favorite color as well. You see some bunch of specific metrics here, and also the performance trends that is there, right? You have a box chart, what's the best score, what's the average score, by balloon color, mean, median, average, all the statistical things that you have, and also average by balloon color. And now we are extracting the real-time data right within this, right? Because you are just kind of simulating the whole data, but you can also do an actual game that is getting played here, all right? I think that's pretty much, I have the demo. You can completely simulate the whole stuff right within your laptop. Go to this whole folder. I'll just share that screen again on the resource slide where I have this whole stuff here. And you can also pull this out and then start doing the whole stuff by yourself. Let me go and share the screen again. And where you can get all these data. I'll share this again, as I said earlier, share all this with Harsh so that you can get this whole data done for you. I think, Harsh, I think I'm pretty much done with my the session. Probably like back to you and probably Manuel to show the great thing about testing content. I think that's something which is cool and interesting as well.
Awesome. I guess we have got a few questions down onto the Slido Q&A chat. So let me just pull them up for you over here. I guess the first question that popped up is, how does Open Catalog compare with Lakekeeper, for example?
That's a great question. Sorry, I should probably go back and check and get back to the answer. This was a very tough question. The very first tough question I'm hearing about this. Probably I'm not aware of what Lakekeeper does. Probably like Open Catalog, I can say Apache Polaris incubating, which is the, as I said earlier, it's open source by Snowflake to Apache Foundation. That stands at the core like any open source project. Open Catalog is the managed Polaris server. If you imagine in this case, I'm kind of running the Polaris server within my Kubernetes cluster. Actually, if you imagine, so you have to run it by yourself, manage by yourself, connect to the S3
Mm-hmm.
tables, and do all of the stuff, right? So instead of that, what we do basically do with Open Catalog is the managed service that is provided by Snowflake, where the same Apache Polaris server is running for you and managed by Snowflake. So that's the biggest difference I can say about like thing. But I don't know about Lakekeeper. Probably that's something which I can check and let you know what's the difference between these two things.
Sounds great. I guess the next question is about any particular considerations when integrating Streamlit with Iceberg for real-time visualization.
See, the only thing right now I was doing is like I was kind of querying it using Iceberg directly, because since it's open catalog format, Iceberg is a SDK that allows you to kind of query the S3 data. In this case, where I was storing everything in S3, Iceberg tables on S3 directly using Iceberg. So I think probably like one of the things you might consider there is like on the performance side, since it's a demo, like I just use that as a thing. But ideally speaking, try to use any kind of optimized query engine like Trino or something else which can query the Iceberg tables and use that as a backend to kind of query the data into the Streamlit, so that like you achieve the actual performance when you're actually putting it a real-time thing.
Yeah, sounds great. I guess the final question for the day would be like any particular reason for using Kubernetes over Docker Compose. The Git looks fine, but the Kubernetes is tough.
Yeah, I think okay, the two things, right? One, if you imagine the number of components that basically are used in this whole demo, right? I have to run Apache Kafka, I have to run LocalStack, I have to run Polaris, I have to run Rising Wave, right? If you imagine like when you start putting all these things in a Docker Compose, technically like there are a lot of other things you have to take in consideration, the networking stuff, how each one talks with each other. And technically your Docker Compose, at least in my opinion, I'm also a big fan of Docker Compose, but it was growing larger and larger and larger, right? Which is end of the day, it's little maintenance headache for me from my personal thing, right? And I'm also like being a Kubernetes developer for quite a long time. I also wanted, my main idea of doing this whole thing is like, how do we get from your desktop, laptop to Qtest, QA, and production, right? So what is your base, right? In those cases, like if you imagine, I want to keep few things inside Kubernetes. Another big thing is like I will be using some amount of secrets, some amount of configuration, config maps, and all these things, right? Which is kind of much easy to create with a thing like Kubernetes-based platform. And a lot of people know Kubernetes right now with the popularity that is gone. And K3 is again, end of the day, it uses Docker for desktop as a kind of thing, and then does this thing, which means I'm making developers or people who are going to use this ready for the next step of development, right? Which is going to be moving from your dev to QA test prod, right? And all the other things that you want to know. Because ideally speaking, like Docker Compose will not be used for production, 100%, in my opinion.
Definitely.
Right? So let's see like how do we actually use Kubernetes. So that gives them the taste of doing and learning journey also. Like how do we wire all these components within Kubernetes, right? And also automation, which is a great piece that I want to target on this particular stuff.
Definitely. I guess that sounds great. Thanks a lot, Kamesh, for coming to this meetup and sharing this really technical talk. It was really lovely to see you here. And I guess as a fact, like for the matter of fact, like as we're building out the whole local stack for Snowflake emulator, I guess we would have like more collaboration opportunities where we can showcase the whole local development lifecycle pretty much on our laptops or our developer machines. So S3, I guess like that's pretty good for a start, but the better things are going to come ahead in the time.
Absolutely.
So thanks, Kamesh.
Absolutely.
Once again, and let's move to the next talk for the day and bring Manuel to the stage. Hey, Manuel.
Hey, hello. Hello.
Yeah, sorry. Yeah, I had a network loss, I guess, on my end. So sorry for the delay, but over to you. I guess the stage is all yours.
Yes, no worries. I was concerned because yesterday Spain suffers a big outage during the entire day, so I was concerned of, oh no, happened again. Well, jokes aside. Well, thank you for inviting me to this local stack community event. So I'm really excited because LocalStack is a great product, a great open source product. Testcontainers project, the Testcontainers project uses LocalStack a lot, or the combination of both projects. It's amazing. I will try to showcase how the usage of both projects in combination will make your life easier as a developer, because many times we have to develop cloud applications. How do we test it? But I'm gonna explain that in my presentation. So, about me, you can find me on the internet as M de la Peña everywhere. You can find me as an open source maintainer in Testcontainers Go since 2020. I've been part of the observability team in Elastic, and before that, I worked with Kamesh in library as part of the library core team. So what are we going to see today? So first, I'm going to present an application, which you are the new team member in a project, and how to get familiar, get acquainted to this application. Then we're going to set up the dev environment to start working on that. We're going to build and deploy this AWS Lambda, which is the particular use case that I'm going to present with LocalStack. We're going to start testing with LocalStack, and finally, we're going to start using Testcontainers Go to go a step further and automating the deployment of LocalStack with Docker in a way that you have a clone and run experience. Everybody that clones the repository doesn't have to configure anything, just clone the project and run the test. This application is a very simple one. It has a persistent layer, cache layer, and streaming layer using Postgres as a relational database, using Redis for caching, and using Redpanda as a streaming queue. Kamesh could confirm that there are multiple streaming options out there, but we chose Redpanda for simplicity. And finally, our application is calculating some statistics about the application using AWS Lambda. Every time we need to request some maths around the application, we do a request. We perform a request against AWS for a Lambda, and we expect the response from that Lambda. How do we set up this? First, we have the application in Go. We have AWS SDKs for Go. Basically, we add it as a dependency. It could be for any other language, Java, .NET, Node.js, etc. But for Go, we just add it to the Go mod file, these dependencies, and we configure them. We set up the AWS SDKs, we configure the credentials, and we start coding. We connect our application to AWS, right? Pretty easy. This is the deployment schema, right? Application, if we want to run the test, we have to set up test environment there in AWS. We have to deploy the Lambda there. Every time we change something in the Lambda, we have to redeploy this Lambda using a zip file or using a Docker file and push into the registry, build that Docker image, for example, and again, be able to test against a live Lambda running on AWS. But this time, it's kind of burdensome, right? There is a lot of work to do, manual work to do in that process. So how do we do that? I'm gonna show real code with how to build this Lambda in Go. So for now, let me switch to my editor. Here in my editor, I have a Go Lambda, which is basically using the packages from AWS to create a Lambda. And it uses a main function to start the Lambda and a handler. This handler is the basic API for Lambda. And in this Lambda, I'm going to spec this payload, which is give me some ratings, and I do some math. In this case, the average and the total count of elements in that for that initial payload. Very simple. And here I'm doing some math, calculating the average, calculating the total count, and giving the response in the right format, which is this response. And here in this is the form. How do we do the deployment of this Lambda? I'm choosing the zip file, which is the simplest one. And here I'm building the Go application in the Bootstrap binary with the right architecture and operating system, in this case Linux and EMD64, and I'm shipping it and put it into my work page. At some point, I have to get this zip file and upload it to AWS. Right? I'm gonna switch again to the presentation, and let me switch it. Cool. So now, as you can see, it's very, very straightforward code. Just one file doing some maths. How do we verify these scenarios? So at the moment I change something or I detect a bug in these calculations, how do I demonstrate that the fix that I provide is resolving the bug, right? I have to do all the process again. I have to zip the application, zip the Lambda, upload it to AWS, wait for the deployment, and do real tests against that dev or test environment for the Lambda, right? Well, we have test environment, but who is providing this test environment for you? Do you have a platform team that is providing it for you? Do you have automation to create this test environment for you? You just run a script and it's there. Do you share this test environment with other teams, with other developers in your own team? So sharing environments could lead to flagginess in the CI or on the test process, because, well, probably that environment is not available at the moment you want to perform your test. How long does it take to provide this environment? It could be minutes if it's automated and you are really lucky. It could be days, or probably you have to fill in a Jira ticket, and in 3 months or 3 weeks, hopefully, you have the environment ready for you because you don't have access, you don't have credentials. Well, a lot of paperwork that you need to complete before getting the environment. And the last question: do you measure your cost, the cost for these test environments? Well, this meme is really funny. So you forget to turn off that instance. It's an issue, or it's a real problem that we see nowadays in many teams. The time that they get, the time they spend provisioning these test environments, right? So in this case, LocalStack appears to simplify this experience, because instead of having to deploy everything to the cloud, to AWS in this case, you just run LocalStack as a local binary in your process, as a host process in your machine, or as a Docker container, which is really handy. As you can see, this is really the numbers from the website from LocalStack. Is really popular project in the community. So as you can see here in the installation instructions, as a process or as a Docker container, right? And the resulting workflow will be more or less the same as the one that we saw before, but the difference is that it happens in your host, right? You start LocalStack. LocalStack will emulate the different AWS services, in this case SNS, Lambda, S3, but the ones that you need. We are going to focus on Lambdas for this use case, and your test, for example, will hit URL from LocalStack, and your test will pass or fail depending on the fixes that you apply to your code. Cool. It's pretty easy. You just run the binary. You have to go to a different terminal, start LocalStack, or start LocalStack as a container with Docker run. But in test containers, the mindset that we want to apply, I want to convince the community about using test containers is that you need a different experience, which is clone and run. So if you set up this LocalStack in code in the place that you need it, which is in the test, when you go to that test and you see, hey, this test is starting LocalStack, everybody in the project, in the team, has the same experience, which is I just clone the project, run the test, and everything is set up for me. I have the mental model next to the code, so the dependencies for this test are split there. I don't have to do. I don't have to check in any other place, right? So in Test Container Go, if in case you don't know this project, well, it's present in multiple languages. Java is the most popular, but Go, .NET, Node.js, Python are really popular in the open source community. And you have your application, in this case Go, you define an import. You add this dependency to the package manager. In this case, Go mod. And finally, test containers consumes the Go package for Docker, the Mobi project, which is an open source project, and well, it's able to start, stop, terminate containers and networks, and you do that in a programmatic manner. So at the moment you need a container, you write, you ask test containers run this container, and in the same way that in a terminal you execute Docker run, you have a test container run function or test container generic container. I will show you it later. You can also, all test containers come with a very handy capabilities with waiting for containers on custom conditions, which is really important for the reliability of the test suite. How many times have you find yourself adding time slips in your CI because the test runner goes faster than the real execution of a container? Of the container needs some time to get reliable, and the test runner or the test machine is faster than that, and those conditions are not met on time. So test container with this concept of wait strategies that allows you to wait for different conditions. For example, wait for a file to be present in the container, wait for an HTTP port to be listening, sorry, a TCP port to be listening, wait for an HTTP request endpoint to respond with a specific HTTP code or HTTP response, wait for TLS for secure connections, wait for logs to appear in the container log, multiple of them. And you can also combine all these wait strategies and create a very consistent and robust wait strategy, so your tests are not flaky anymore, because the test runner will be blocked until those conditions are met. More about capabilities in test containers is that you can define lifecycle hooks and inject your custom code before and after the container event. You can execute code before the container is created and after it's created, after it's started or before it is started, after you terminate or before you terminate the container. It's really cool, this capability, because it allows you to add more granularity and more flexibility to the way you customize the containers you depend on. And finally, well, we have two major features, which is copy APIs to copy files into the container and copy files from the container to inspect the result of the state of the container, right? And we have a garbage collector, which is Ryuk, which is a companion container, which is taking notes of which containers, images, volumes, and networks are created by test containers, and kill them all at the end of the test execution. I didn't mention, but Test Containers is an open source project, MIT license, so you can start adding it to your projects with no risk, because, well, it's an pure open source library. We have also the concept of modules, which is based on the core functionality of test containers. We are adding specialized containers for given technologies. We have a module, a Go module for LocalStack, Go module for Google Cloud, Azure, relational databases like MySQL, Postgres, vector databases for the AI space, non-relational databases. So more than 70 Go modules. You can go to this URL to see the examples of what technologies we support. And this is really handy because with just one line, for example, for LocalStack, you have a LocalStack running. And it's really cool because you see your test code, which I will present right after this. And you see the first line of the test code is LocalStack run. So you are preparing the dependencies for this test to be successful, right? This will be, again, the new workflows. You have your application, test containers is a test dependency. It will start the Docker container for LocalStack, and LocalStack will emulate the services that you need. In this case, test containers will pull from Docker Hub, so it's transparent for you. You don't have to do anything else. If your terminal, the terminal you are running, is authenticated against the registry, public or private registry, automatically test containers will pull the images from that registry if the credentials are there in the Docker config file. For this demo, I'm going to use Test Containers Cloud, which is a Docker project, a Docker product, which is really handy because, well, I don't have a big machine in my computer because or my CI worker. At the moment that I have to run multiple containers, they will be spawned for me in the cloud, right? I'm gonna present this demo now. I'm gonna switch to the editor, and this application to interact with the Lambda, which is the one that I'm interested. I have an HTTP client, which is, I call it Lambda client. Very simple. It defines an HTTP client and the URL or the Lambda. So when I create a new client for this Lambda, I receive, this is the location of the Lambda, and I'm able to perform requests there. This is the payload, this is the expected response. If I'm gonna calculate some histogram about a given payload, what will be the response? I prepare the payload here and submit it with a post request to the URL of the Lambda, right? Pretty simple, HTTP, using the HTTP layer here to communicate or to talk to the Lambda. So how do I test this? As I said before, Testcontainers and before LocalStack, I had to zip file the Lambda, deploy it to AWS, and do it again and again and again. So here I'm gonna, you already saw the code of the Lambda for that. So here now I'm using a test in Go. We have test files, and in this test file I'm gonna have a helper code, a helper function which is built in the Lambda, which is calling zip, make zip, a wrapper on top of make to build this, to automate the creation of the Lambda. And here I'm gonna start LocalStack as a test containers module. Here we have the module, the image that I'm gonna run. I'm gonna add some environment variables to this LocalStack container using the Testcontainers APIs. In this case, I'm gonna tell LocalStack that these are the services that I need in this container. And also, I'm gonna add some flags to the Docker container because when the containers are started, we need some labels to be present on that. Why? Because those containers need to kill those containers, the containers that will be spawned for the Lambda. We need to prune them out after the test finish, so they are not leaking our system, and we don't have more containers running than the ones are expected. Also, I'm gonna copy the zip file into a well-known location in the container. In this case, the zip file, which is the output of the make zip command. I'm gonna put it inside the container using the Testcontainer API with files. And I'm gonna customize the lifecycle hook, the ones that I mentioned. After the container starts, I need to create a Lambda in this container. So I'm gonna call the local binary AWS local Lambda, which is already present in the LocalStack container. So I'm gonna, as I said, as is said here, I'm gonna create a Lambda function. I'm gonna create the URL function configuration for this Lambda function, and I'll wait for the Lambda to be ready. So this will be the first command to create the Lambda. The second one, I'm gonna create the function URL config for that. And once this Lambda is active, I'm gonna continue. So running there, I'm gonna Lambdas, and if there is no error, Lambda function will be created, and the Lambda will be satisfactorily will be in the container. Finally, I'm gonna list the config URL for that Lambda to get the URL, the actual URL, because LocalStack will provide me with a URL dynamic and ephemeral URL for that Lambda. And for that Lambda, I'm gonna, well, this is the struct representing the function URL. I'm gonna get the function URL here from this element, and I'm gonna calculate the URL provided by Testcontainers. I didn't mention before, but Testcontainers provides you random ports for all the well-known ports of a given technology. In this case, LocalStack is the 4566 port. Why Testcontainers give you random ports? Because we want you to run tests in parallel. So at the moment you have fixed ports, you only can run one LocalStack or one database in that single port at the same time. With Testcontainers, by default, it's possible to run multiple containers of the same technology in different ports, because Testcontainer will give you a random port for that. So these APIs allow you to discover the random port or the well-known port, and we're gonna update the URL provided by LocalStack with the random port from Testcontainers. And finally, we need this to update the LocalStack URL for that Lambda, because I will show you how this URL looks like. And at the end, I'm creating my client. I'm gonna perform a HTTP post request to that URL. I'm gonna verify that for this payload, those are the stats, right? Let me run this test here in the IDE. The cool thing is that we can run and debug. I'm gonna run it. Here you see the test container logs, container created. This is the LocalStack. Here you can see Ryuk, the container that we're gonna kill LocalStack at the end of the session. Test session container is ready. The tests are passing. 14 seconds. I'm able to reproduce this development workflow of the uploading and downloading. Sorry, I'm uploading and checking that the AWS Lambda is passing. But well, never trust a test that doesn't fail, right? Imagine that I'm going to the Lambda and I commit a mistake here, and I'm gonna introduce a bug here. I'm gonna set that this Lambda is going to calculate the average in a very, very wrong manner. Let's run the test again. I'm gonna run it first, and you will see that the test should fail. Starting the test, starting the container, is building the Lambda, building the zip file. It failed, right? As expected, because it's expected this value, and it got a really way bigger number for the average. So we caught the bug, and here we can demonstrate with a test that the code, the fix in this case, is incorrect. I'm gonna return this back. So our application is able to verify that the client code for LocalStack or for the Lambda is doing well, right? Is behaving as expected. But what happened with the team building the Lambda, for example, because we could be separate teams. For the Lambda, I have here a separate directory, which is Lambda Go, and this is the code that I showed you. We can write also integration tests for this team, and this team is able to iterate really, really fast while building the Lambda. They just do exactly the same. Zip the Lambda, get the LocalStack container with the right configuration, and at the end perform the assertion. Really, really fast, and in the order of seconds, you have the full development life cycle of testing that a fix is correct, right? Let me go back to the presentation again. Cool. And I'm gonna present you one last thing regarding test containers. Now that you know how to write integration tests, you have any question later, please send them out in the Q&A part of the presentation. But I'm gonna present you also about local development experience with test container, because we created tests, but why not creating containers for starting the application in dev mode? So it's and start the application with run, go build, and explore the application doing manual testing for this application, right? So let me switch back to the editor, and here we're gonna see a file which is dev dependencies. In Go, we have the concept of init functions, and init functions are functions that are executed before the current code, the actual code, right? Also, we have the concept of build tags that allow you to selectively add files to the Go toolchain for the build, for test, etc. So if we leverage both concepts, we are able to just add this file, this dev dependencies file, only when these build tags are applied to the Go toolchain, and this init function will be executed only in those cases, right? So here we're gonna start the database, the queues, the cache, the Redis cache, and the Lambda in the same way that we did before. But instead of running tests, when we run the application, when we want to explore it. So for example, if I'm going here to a terminal and I run, let me show you the make file. So here, this make file, we have a make dev command, which is running the application with the dev tag. If I run make dev, here, it's gonna tip the file because these dependencies have the same code here to build the Lambda and start the Lambda, exactly the same in the test. Probably we could talk about abstracting this in a separate module because we have here how to run the local stack in test time and dev time. But well, for the purpose of demonstrating how to use it, I think it's clear enough. So now we are here running a web application. It's gonna build it. It's using Gene, the web framework. And once we have this, let me open a terminal here, curl HTTP localhost 8080, and we have some metadata. Let me paste this in a new file. So you format document JSON. So you see document. The format of this endpoint, the root endpoint for this application, is just exposing where are the services in the application and where do they live. So we have a ratings Lambda, which is the URL for the Lambda. So LocalStack, whenever this your endpoint is called, will start a container representing the Go application. So if we call, and as you see, this randomized name. So whenever we deploy a new Lambda, this or new local stack, this thing will be different. So it's really cool that we're able to discover this at dev mode. The application is running, so I could send post requests now to this URL in the random port from Testcontainers. Let me clean out this Docker PS. For Docker PS, we can see here the Red Panda, Ryuk, Alpine, Postgres. Let me look for it. Here, local stack. Here we have the local stack, and this is the same port, 32780, mapping the 4566 well-known port of local stack. So Testcontainers will produce this, and we are able to discover the URLs for this Lambda. So with Testcontainers, we were able to write tests, integration tests for this layer of the application, and we are able also to explore the application in dev mode with total confidence, because we will have our application running with Go run, and all the backing services, in this case Redis, Postgres, Red Panda as a streaming queue, and LocalStack provisioning the Lambdas on demand, and it's really, really, really handy. Let me go back to the demo again. And this is what I have. Just something that I want you to go back on with is that Testcontainer Go and LocalStack is a powerful combo. It's really easy to use. As you saw, you just add the dependencies for Testcontainers, and because everything is packed into a Docker container, the container will handle it really, really smoothly and enriches the experience for local development. Also, writing integration tests will give you enough confidence to make progress, but it doesn't mean that you don't have to test against the real thing. So you also want to test against AWS. But instead of running all single tests, all pull request tests, all your explorations locally against AWS, probably expanding or increasing your build cost, your cloud bill, you experiment with them locally without increasing that. But at the end of the day, you also need a battery of end-to-end tests against the real thing. but it allows you to make a lot of progress with test containers. And finally, the dev mode, which is using leveraging init functions and build tags, you are able to spin up the application, wire up the dependencies while you are working on it in a really, really easy manner. And this is what I have. I hope you find it interesting.
Awesome. Thanks, Manuel, for this exciting setup and a really exciting demo. I just hope that my internet does not freeze right now, just like the last time that it was like having some issues. So I have got like a few questions down on the chat, so maybe I'll just bring them up. The first question, and this is something that even I would like to know, because last week I was writing test containers tests using Java, and I had a really, really hard time getting this through. So just going through a lot of ChatGPT and making sure that I can get all the right recommendations in. But what are the tricks that you would suggest around like debugging Lambda issues inside the container, especially like when stuff basically goes silent?
Yes, I haven't done it before, but looking at the deployment model for Lambdas, I will say that instead of using a zip file, you use a Docker image. And in that Docker image, you expose the debugger port for Go, and you are able to, at the moment you are connect to the debugger to that remote port. I would suggest that would be the easiest way that comes to my mind at the moment.
Sounds great.
Also, you can add instrumentation to the Lambda, adding logs and traces that you can send to a remote collector using OpenTelemetry or something like that, and you can observe the execution of that Lambda.
Sounds great. I would also like to plug in that we have a new Lambda debug mode as well. So if you can mount your debug mode configuration and set up a specific configuration variable when you're creating the local stack container, you should be able to specify the Lambda function ARN and which debug port that you would really like to open. And you can pretty much like debug Lambda functions on the fly. So maybe we can do a blog on this sometime in the future, where we can use test containers to like write tests while using the Lambda debug mode for debugging those Lambda functions. The next question,
fantastic.
Yeah. The next question that popped up was like, I see modules are written for every language. So is there any parity between all the modules or a way to make these models language agnostic?
This is a good question. It's something that internally we are discussing in the team. It's difficult to create a module that is agnostic to all the languages, because one of the goals of test containers as a project and also for us as maintainers is to be idiomatic to each language. So in Java has some idioms, Go has some idioms, Python, .NET, etc. And it's difficult to generate code for all of them, and the code doesn't seem so ugly, honoring those idioms. That's why we try to talk the different maintainers and build them the modules with the same, at least the same foundational concepts, with respecting or honoring the idioms in each language. Regarding parity, Java is the language that came first and is the most popular because there is a lot of adoption in the different Java frameworks, Micronaut, Spring Boot, Quarkus. They adopt test containers as a runtime dependency for dev mode, and is really popular. But the rest, so because of that, there are more modules in Java. But we maintainers are trying to keep up with them and build all the modules that are interested by the community. We did a lot of effort for the AI modules, for vector databases, to support all the guys doing AI stuff in the different languages. So yes, it's a good question, but it's difficult to have one module that is agnostic to all the languages.
Sounds great. I guess we can take up one final question for the day, and it would be around that if there is a monorepo containing multiple microservices, would you spin up one local stack container per module or share a single instance?
Well, this is a really good question too, because I always suggest when adopting test containers, I always suggest starting one container per test method or test function. Even though it could be a big image, a small image, I don't care, because in the end of the day, Docker or any container runtime technology provides the ability to spin up containers in the order of at most 10 seconds. Probably when you spend most time pulling images than starting them up. But in any case, you just pull once, or probably you get the worker with the prepared images already pulled, so you reduce that time. But I always suggest starting with one container per test method. Why? Because with test containers, you are able to, you won't have port collision. And this is really important.
Definitely.
So if your host is able to handle the load of having 10 containers at the same time, why not? Why not?
Sounds great. And I guess this is where Testcontainers Cloud might also come in, because you can directly run all of those tests on the cloud, on the fly. And I had the opportunity of kind of interacting with Sergey like a couple of years back and seeing the whole Testcontainers Cloud in action. It was a magical experience. Like, imagine like not waiting for minutes or even like a few seconds for your test to run. Like, you just run a button. So you run a command or click a button and you have all the tests running on the cloud directly. So that was fantastic.
Yes. You didn't notice, but I was using Testcontainers Cloud in my demo.
Yeah, definitely.
Automatically, it gave me a remote host, ephemeral one, on demand, the closest to me. I'm in Spain, so in a region which is close to me, or the closest to me, and you feel it is instant. Probably you are paying extra milliseconds for that, but the experience is almost instant. So it's mind blowing, because my machine is not hitting. It's not hitting my coffee anymore.
Definitely. That's a magical engineering like outcome. So first of all, thanks Manuel for being a part of this meetup and just giving us like really good insights around test containers, Go-based Lambda functions, and LocalStack. Like really cool things that you almost like learn every single day. I guess we will be in touch.
Sorry, I forgot. There is one slide more. We can go there, because with a QR code with the resources. Here, I forgot to add it here. So you can find here the resources for the workshop. This is a workshop that is available on GitHub. Also, the library and a QR code with that. I noticed a bug, so this is my fault. M de la Peña is with NYA, but well, you will find it in my LinkedIn, in my GitHub, very easily.
Sounds great. Awesome. Thanks a lot for sharing all these resources. And maybe what we can do is jump right into the conclusion. So before we conclude for the day, I have a couple of call to actions that I would really like to share with all of you. First up, if you are joining us from London and you are going to participate in the AWS Summit London, which is going to start from tomorrow, I guess, then LocalStack is going to be over there. So if you're participating in that, please find us at booth B52. And you will be directly engaging with a lot of people from our leadership team, our core software engineers, front-end engineers, project managers, and they would be more than happy to just walk you through all the cool stuff that we have been building at LocalStack and how we can help you develop and test your AWS cloud solutions on your local machine, alongside a vast array of different OSS tools out there. So some exciting hands-on demos, some exciting swags, some exciting technical deep dives. So do join in and do interact with our team members. The next pointer that I would like to share is that like LocalStack 4.4 would be coming out next month. So in the last meetup, Brian mentioned that 4.3 came out just on the day that we were having the meetup. So we didn't had an opportunity to kind of walk you through all the details. So if you have not upgraded to LocalStack 4.3 yet, then do visit blog.localstack.cloud and look at the release notes that we have posted for you. And that should be enough for you to get started with that. But 4.4 is coming out and it has got some really exciting features. It has got support for verified permissions, which is a completely new service provider that we have added support for. We have added tag support for application autoscaling provider. We have a new Lambda Ruby runtime. And we have also like AWS replicator support for Route 53 hosted zone. So this is like just the start of it. You'll see like more exciting stuff coming out in the release. So stay tuned on our Slack and on our socials. And you will be the first to know when this basically gets out. And the final note that I wanted to share is that starting this week, we are basically kicking off a new question of the week in Slack. So this is the best opportunity for you to join our Slack community, which has got many thousands of members around here. So you can join the Slack channel directly at slack.localstack.cloud. This will prompt you to create a new account if you have not done that already. And the best part about like this question of the week is that it's going to be a fun way where you will be sharing some ideas, swapping stories, and also kind of steering our direction around what is going to come next. So every week we are going to post a new question in the announcements channel. Those will be super quick to answer, and we would love to hear from as many of you as possible. So don't feel shy, participate in, and we would love to hear your thoughts and see what exactly have you been thinking about LocalStack coming out in the future. So with that said, I guess that's the end of it. It was great to host a meetup after a really long time. We will be back next month with some more exciting demos, more exciting topics. And if you haven't joined our meetup already, now is the best time to do that. We have just crossed 900 members, which is pretty surreal because we started almost 3 years back. And back then, this was a really simple experiment. But who knows, like your joining our meetup community will just help us reach the golden 1,000 number. So I'm hoping to see you all again next month, and I hope you have a great rest of the day, folks. See you soon.